Good morning. Today we will discuss remaining properties of inverse trigonometric functions and then we'll solve sums from the exercise. Okay. Now we begin with result number 16. Cosec inverse x. Many students think that cosec inverse x is 1 upon sine inverse x. That is absurd. Yes, cosec x is 1 upon sine x. That is true. But cosec inverse x is sine inverse 1 upon x. Same is true for other results also. See, suppose cosec inverse x is y. Invert the relation. What is x then? Cosec y. So if x is not equal to 0 and x cannot be because cosecant theta cannot be 0. So take the reciprocal. So it is 1 upon x. It is reciprocal of cosec y, which is sine y. Now invert the relation. So y becomes sine inverse 1 upon x. But we have put y for what? Cosec inverse x. And therefore cosec inverse x is nothing but sine inverse 1 upon x. This part will not be asked in exam. In fact, we have done this in derivatives, right? See, same is true for other ratios. 17th also we have done. In fact, 17, 18, 19, 20th. All results we have at least either proved or verified. Now, result number 17. Sine inverse of sine x is x. We can easily verify this provided x belongs to this particular domain. In fact, x has to lie between minus pi by 2 both included. Take x equal to say pi by 6. What is sine pi by 6? It is half. So sine inverse half is the angle whose sine ratio is half, pi by 6. Simple. What is sine of sine inverse x? It is x. We can verify this. Take x equal to 1 by root 2. So what is sine inverse 1 by root 2? Pi by 4. And what is sine pi by 4? 1 by root 2. Is that clear? So result number 17 is verified. Then result number 18 is important. Sine inverse x plus cos inverse x is pi by 2. We will verify this. Suppose x is half. If you say take x equal to 2, that is absurd because x has to lie between minus 1 and 1, both inclusive. Take x equal to half. What is sine inverse half? Sine inverse half is the angle whose sine ratio is half, that is 30 degrees, plus cos inverse half. What is cos inverse half? It is the angle whose cosine ratio is half, that is 60 degrees, right? 30 plus 60, 90, that is pi by 2. Okay. Now result number 19. Sine inverse of minus x is minus sine inverse x. Tan inverse of minus x is minus tan inverse x. But note that cos inverse of minus x is not minus cos inverse x. It is pi minus cos inverse x. See, logic is simple. What is the range for cos inverse x? It is closed interval 0 to pi. See, I'll tell you. For sine inverse x, what is the range? If I say y equal to sine inverse x, then it is closed interval minus pi by 2 to pi by 2. And that is why it is logical that sine inverse of minus x is minus sine inverse x. For y equal to tan inverse x, tell me what is the range? It is open interval minus pi by 2 to pi by 2. Okay. Now, just a minute. Now for y equal to cos inverse x, can you tell me what is the range? Yes, it is closed interval 0 to pi. And therefore, cos inverse of minus x is not minus cos inverse x, it is pi minus cos inverse x. Okay. Now, This part is very important. Result number 20. Tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus xy. Tan inverse x plus tan inverse y is pi plus tan inverse x plus y upon 1 minus xy when xy is greater than 1, because when xy is greater than 1, this becomes tan inverse of negative number, right? See, now you will ask me, in fact, I will tell you the proof also why this is pi plus if xy is greater than 1. Okay. But as far as differentiation is concerned, this makes no difference, because even if you say pi plus, derivative of any constant is 0. That is why we just took tan inverse x plus tan inverse y as tan inverse x plus y upon 1 minus xy in case of derivatives. But here in trigonometric functions, if x and y both are positive and if xy is greater than 1, then tan inverse x plus tan inverse y is pi plus. Okay. A proof will not be asked, but I'll tell you the proof of this. Now, what is tan inverse x minus tan inverse y? It is tan inverse x minus y upon 1 plus xy. We will discuss these two results, even if the proof of one is sufficient. Suppose tan inverse x, don't write, is alpha, and tan inverse y is beta. Okay. So what is x? X is nothing but tan alpha and y is nothing but tan beta. Is that clear? Now tell me, what is tan of alpha minus beta? See, every time we have to take care of domain and range of the function. What is tan of alpha minus beta? Tan alpha minus tan beta. So I just write x minus y upon 1 plus tan alpha tan beta, that is 1 plus xy. Invert the relation. So alpha minus beta becomes tan inverse x minus y upon 1 plus xy. Now what is alpha? Alpha we have taken for tan inverse x, minus what is beta? Beta we have taken for tan inverse y. That is the reason. See, in case of derivatives, we use this result. Finding derivative of this function is not that easy. So we can express this tan inverse x minus y upon 1 plus xy as what? Tan inverse x minus tan inverse y. Okay. So at present, just remember these results. So using these results, we are now in position to solve sums from this exercise. Question 3, I think from which exercise? 3.2, right? No, 3.3. Okay, 3.3. So the question goes like, prove that sine inverse 1 by root 2 minus 3 sine inverse root 3 by 2 equal to minus 3 pi by 4. We begin with, let sine inverse 1 by root 2 be alpha. Alpha belongs to this closed interval. So sine alpha is 1 by root 2. Now the angle having sine ratio 1 by root 2 and lying in this interval is pi by 4. So what is alpha? Sine inverse 1 by root 2, it is pi by 4. Similarly, we say let sine inverse root 3 by 2 be beta. So sine beta is root 3 by 2, but sine pi by 3 is root 3 by 2, right? So beta has to be pi by 3. Now LHS equal to, therefore LHS equal to sine inverse 1 by root 2, say it's just playgroup sum, minus 3 times sine inverse root 3 by 2. That is pi by 4 minus 3 times pi by 3. So this is nothing but pi by 4 minus pi, LCM is 4. So pi minus 4 pi So it comes out to be minus 3 pi by 4, which is nothing but right hand side. Now the second is for homework. I have just written the values. You can see the sum. Prove that sine inverse minus half plus cos inverse minus root 3 by 2 is cos inverse minus half. This is the value of sine inverse minus half. This is the value of cos inverse minus root 3 by 2. Please remember, for cos inverse x, the range is closed interval 0 to pi. So your answer should lie in this interval only. If you write otherwise, means you are lying. What about RHS? It is cos inverse minus half. Yes, it is 2 by 3. Okay. You can write the solution afterwards. Now, from third sum, these sums are important and can be asked in exam. Third one, prove that sine inverse 3 by 5 plus cos inverse 12 by 13 equal to sine inverse 56 upon 65. Let sine inverse 3 upon 5 be alpha and cos inverse 12 by 13 be beta. So sine alpha is 3 by 5. Clearly alpha lies in first quadrant. See, for sine inverse, what is the range? Minus pi by 2 to pi by 2, right? But as this ratio is positive, clearly angle lies in first quadrant. Now, the simplest method to find cos is by constructing a triangle. Now, sine is 3 by 5. So, opposite upon hypotenuse. So, by corollary of Pythagoras theorem, adjacent side is 4. Now, alpha lies in first quadrant. So, cosine ratio is positive. It is adjacent side upon hypotenuse. So, 4 by 5. Now, cos beta is 12 by 13 because I have put cos inverse 12 by 13 equal to beta. Now for cos inverse, range is 0 to pi, but cos beta is positive. So beta has to lie in first quadrant because in second quadrant cos beta is negative. Here it is positive. Simple. Again construct the triangle. Cos is 12 by 13. So adjacent upon hypotenuse. So that gives me opposite as 5. In first quadrant, sine ratio is positive. So sine beta is what? It is opposite upon hypotenuse. So we have obtained cos alpha and sine beta. Now sine of alpha plus beta. You may ask me why to find sine only, why not cosine or any other ratio? The reason is simple. On right hand side we need sine inverse and that is why we find sine of, so that we can invert the relation to get alpha plus beta equal to sine inverse. As simple as that. Now sine of alpha plus beta is sine alpha cos beta plus cos alpha sine beta. Substitute the values to get 56 upon 65. So what is alpha plus beta? Sine inverse of 56 by 65. But we have put alpha for what? Sine inverse 3 by 5 and beta for cos inverse 12 by 13. And therefore sine inverse 3 by 5 plus cos inverse 12 by 13 is sine inverse 56 upon 65. Right down. Fourth one, prove that cos inverse 3 by 5 plus cos inverse 4 by 5 is pi by 2. See, when you see right hand side as pi by 2, you should think of which result? Sine inverse 4 by 5 plus cos inverse 4 by 5 is pi by 2. Or you may say cos inverse 3 by 5 plus sine inverse 3 by 5 is pi by 2. Same thing. And that is why I expressed cos inverse in terms of sine inverse. See, let cos inverse 3 by 5 be alpha. So cos alpha is 3 by 5. As cos is positive, alpha has to lie in first quadrant, in which sine ratio is also positive. So from the triangle, what is sine alpha? Plus 4 by 5. So what is alpha? Sine inverse 4 by 5. So we have expressed cos inverse 3 by 5 as sine inverse 4 by 5. Keep second term as it is. So tell me what will be left hand side now. Therefore, cos inverse 3 by 5 plus cos inverse 4 by 5 equal to sin inverse 4 by 5 plus cos inverse 4 by 5, which is nothing but pi by 2. That's it. You have to write reason also from 1. Fifth one, prove that tan inverse half plus tan inverse 1 by 3 is pi by 4. Now, what is tan inverse P plus tan inverse Q? It is better if you mention that formula in exam, because if this is asked for 2 marks, examiner will expect to write that tan inverse P plus tan inverse Q is tan inverse P plus Q upon 1 minus PQ if PQ is less than 1. Here the product is 1 by 6 less than 1, and that is why I haven't added pi. If PQ is greater than 1, then it is pi plus. Okay. Now substitute the values to get tan inverse 1. But what is tan inverse 1? Pi by 4. Same as right hand side. Sum number 6. Prove that 2 tan inverse 1 by 3 is tan inverse 3 by 4. Now, you may say there is standard formula. Yes, it is mentioned in the textbook, but I expect you to write this as tan inverse 1 by 3 plus tan inverse 1 by 3, and then use tan inverse P plus tan inverse Q as what? Tan inverse P plus Q upon 1 minus PQ. So on simplification, see, I have multiplied numerator and denominator within bracket by 9, and that is why I have written 3 plus 3. Otherwise, you may ask me, sir, how come 3? I have multiplied all the terms in numerator and denominator by 3, by 9 rather. So 3 plus 3 upon 9 minus 1. So 6 by 8, that is 3 by 4. So it is tan inverse 3 by 4. आलाय का करता? Okay. Sum number 7. Prove that tan inverse cos theta plus sin theta upon cos theta minus sin theta is pi by 4 plus theta if theta belongs to open interval minus pi by 4 to pi by 4. Okay. So begin with LHS. What is LHS? It is tan inverse cos theta plus sin theta upon cos theta minus sin theta. Okay. Now within bracket, divide numerator and denominator by cos theta. I'm not writing that, but in exam you have to write divide numerator and denominator by cos. So that is 1 plus what is sin by cos? Tan. So 1 plus tan theta upon 1 minus tan theta. Okay. Now next step is important. See, can I directly write tan of pi by 4 plus theta for this, or I may add one more step. This one I can replace by tan pi by 4. So tan pi by 4 plus tan theta divided by 1 minus tan pi by 4 into tan theta. I hope you are getting this. So this is nothing but tan inverse of tan of pi by 4 plus theta, because this is the expansion of tan of alpha plus beta. Now, what is tan inverse of tan of any angle? It is that angle. So it is simply pi by 4 plus theta, which is nothing but right hand side. Now sum number 8. Prove that tan inverse root 1 minus cos by 1 plus cos is theta by 2. See, 1 minus cos theta is 2 sin square theta by 2. 1 plus cos theta is 2 cos square theta by 2. So it is simply tan square theta by 2. So what is its root? Tan theta by 2. So tan inverse of this is tan inverse of tan theta by 2, which is nothing but theta by 2. Now miscellaneous exercise 3. First question, select the correct option from the given alternatives. First one, the principal solutions of equation sin theta equal to minus half r. I hope you remember this. Principal solution has to lie between 0 to 2 pi, 0 included, 2 pi excluded. In 99% of the cases, you get two answers. But if you are given equation like rather identity, not equation, like sin square theta plus cos square theta equal to 1, then this may have infinitely many principal solutions. Okay. Now sin theta is minus half, that is minus sin pi by 6. You should know allied angle formulae. Sin of pi plus theta is minus sin theta. Sin of 2 pi minus theta is also minus sin theta. So 7 pi upon 6, 11 pi upon 6. So the correct option is B, Bombay. Second, the principal solutions of equation cot theta equal to root 3 are. Cot theta is root 3. So what is tan theta? 1 by root 3. But tan pi by 6 is 1 by root 3. Tan of pi plus theta is also tan theta. So pi by 6 and 7 pi by 6. So the correct option is A, Ahmedabad. Third question, the general solution of sec x equal to root 2. Sec x equal to root 2, so cos x is 1 by root 2. That is cos pi by 4. Now you should remember that cos theta equal to cos alpha has general solution theta equal to 2n pi plus minus alpha. So here x equal to 2n pi plus minus pi by 4, where n is an integer. Correct option is A, Ahmedabad. Fourth MCQ, if cos p theta is cos q theta, p not equal to q, then now what is the general solution? P theta equal to 2n pi plus minus q theta. Bring this to LHS. So this becomes minus plus, same as plus minus. So p theta plus minus q theta. Take theta common to get p plus minus q into theta equal to 2n pi. Now p is not q. So p plus minus q non-zero, so division is allowed. So what is theta? 2n pi upon p plus minus q. Correct option is A. Fifth one, if polar coordinates of a point are 2 pi by 4, then its Cartesian coordinates are. See, polar coordinates are 2 pi by 4 means r is 2 and theta is pi by 4. So x is r cos theta, that is 2 into, what is cos pi by 4? 1 by root 2. 2 by root 2 is root 2. Y is r sin theta, that is 2 into sin pi by 4, again 1 by root 2. So root 2 root 2. Correct option is D. Sixth one, if root 3 cos x minus sin x is 1, then general value of x is, see the working rule is simple. If it is, I am talking about general expression, a cos x plus b sin x, you have to divide both sides by root a square plus b square. So here we will be dividing by root of root 3 square is 3 minus 1 square is 1. So root of 4, that is 2. So divide both sides by 2 to get this. Now root 3 by 2 can be replaced, rather should be replaced by cos pi by 6 and this by sin pi by 6. So left hand side is expansion of cos of x plus pi by 6. You can check that. Now right hand side 1 by 2 can be replaced by what? Cos pi by 3, right? Now cos theta equal to cos alpha has general solution theta equal to 2n pi plus minus alpha. But theta is x plus pi by 6. Again rearrange the terms to get correct answer as 2n pi plus minus pi by 3 minus pi by 6. So correct option is C, Calcutta. Seventh, actually there is one correction. Option A should be 2 is to root 6 is to root 3 plus 1. I repeat, option A should be 2 is to root 6 is to root 3 plus 1. So what is given? Angle A 45 degrees, angle B 60 degrees. So angle C has to be 75 degrees. Actually sin 45 is 1 by root 2. Sin 60 is root 3 by 2. We do not know sin 75. We can find by writing 75 as 45 plus 30. But let us see, without finding sin C, we get the answer or not. Now A is to B is to C is sin A is to sin B is to sin C. That is 1 upon root 2 is to root 3 upon 2 is to, suppose sin C is K. Now multiply throughout by 2 root 2. So 2 is 2. What is root 3 into root 2? Root 6 is 2. Now this happens only in option A. Otherwise, you may say we will find sin C and so on. That is also correct. But I think it is not required here. We can directly say that correct option is A, Ahmedabad. Sum number 8. In triangle ABC, if C square plus A square minus B square is AC, then angle B is. Use cosine rule. Cos B is A square plus C square minus B square upon 2AC. But numerator is given to be AC. Substitute. So cos B is half. So B is 60 degrees. That is pi by 3 radian. Correct option is B, Bombay. Ninth MCQ, we'll solve one more and then we'll stop. Ninth, in triangle ABC, AC cos B minus BC cos A. Use cosine rule, simple, for cos B and cos A. Simplify, here AC gets cancelled, here BC gets cancelled. LCM is half. So numerator 2A square minus 2B square. Denominator is 2. So we get A square minus B square. Correct option is A, Ahmedabad. This is the last MCQ for today. Uh, if in triangle, the angles are in AP. So A plus B plus C is 180 degree. Now angles are in AP. So middle term is arithmetic mean. So 2B is A plus C. So in fact 3B is pi. So angle B is pi by 3, that is 60 degrees. Now B is to C is sine B is to sine C is root 3 is to root 2 given. Sine 60 degrees is root 3 by 2. So from this I get sine C as 1 by root 2. So C is 45 degrees, that is pi by 4. So it is angle A 180 degrees less 60 plus 45. So 75 degrees. So the correct option is C, Calcutta. So that's it for today.